Example 9. Let's see how y'all did. So we talked yesterday about solving trigonometric equations. Did anyone divide both sides by tangent? Anyone do that? Would that be legal? No, why not? What? It's Friday. Would it be legal on a Monday? When you divide through by tangent, do we have any tangents anywhere else in the problem, or did we lose it completely? You lost it completely, and it had a variable in it. So when you do that, you lose possible solutions. So that's not what you want to do. So instead, get everything on one side and set it equal to 0. And then you're going to divide out the tangent, but you're going to divide it out in a factoring out format so it still remains in the problem. Now, it does say to find all the solutions. So remember, we did that yesterday. That's going to be from negative infinity to infinity. We'll find the ones within one rotation and just add 2 pi to it. So now you can divide out the tangent, but again, you're factoring it out. And when you set each of them equal to 0, now you get tangent of x equals 0, which we would have lost if we had divided out in the beginning. Or you're still left with what you would have had you divided out the tangents. So now it's unit circle time. Where is tangent equal to 0? Within one rotation? 0 and pi. Yeah, good. 0 and pi. So to get all of them, you could say plus 2 pi n, where n is an integer, of course. And then the other one, same thing, plus 2 pi n, where n is an integer. Now, in this case, you can actually combine these to a single equation because 0 and pi are a half a rotation away from each other. You can actually say x equals 0 plus, instead of 2 pi n, you could just say pi n. You can't normally do that if you have solutions that fall within the quadrants. But for these that are a half rotation away, you could do that. So we would have lost those had we divided out tangent. And then over here, when you solve, you get cosine equals 1 over the square root of 2. What's another name for 1 over the square root of 2? Square root of 2 over 2. Yeah, so that puts it in a more recognizable format. So now from the unit circle, there's 2 answers. Where is cosine equal to positive square root of 2 over 2? Pi fourths and 7 pi fourths. Excellent. Plus 2 pi n, where n is an integer. And then over here, plus 2 pi n, where n is an integer. Now here we can't combine those into a single equation because pi fourths and 7 pi fourths, they don't live half rotation away from each other. So there's no way to get one of them and then have some constant multiple to get you to all the rest of them. So the solutions then are going to be either the ones in the box, or of course you can substitute that one for the left side. And that's it. We're good. I think you can do that Tuesday on a quiz. If the answer is no, good news is it's only Friday. You'll still have lots of time between now and then to exhibit your student-athlete aspect of your personality. You can practice. You can practice. Okay, example 10. Find all solutions. What is that? A trident, a Y, a pitchfork, a sigh. Good. Like a sigh of relief, PSI. That's the Greek letter psi. Anyone here into psychology? Psychology, I get it. Yeah, good. So do they. They actually get it too. That's the symbol for like the National Psychological Association, because it is the Greek letter psi, which is the initial sound for their field of study, psychology. Right. Yeah. So anyway, it's just another letter. In this case, it represents an angle. We want to find all the solutions from negative 4 pi to 0. That's like 2 negative rotations. And then look, Thornhill, there's like a bad pun built right into it. And then breathe a sigh of relief. Oh, ha ha. All right. 3 sine of psi equals 2 cosine squared of psi. Sweet. This one's going to be fun. Any ideas what to do first? Take suggestions from the studio audience. What have we been doing? Set it equal to 0. Yeah, so let's bring everything across. So 3 sine of psi. And again, if you don't like the variable, you can kind of change it in the beginning. I like psi. He's a good guy. All right, and now once we set it equal to 0, our goal is to factor it. We look for common factors. Do we have anything besides 1 or negative 1? Nope. Anything else? Nope. Can't factor anything out. So what to do? This is where identities come into play. Anybody have an idea? Cosine. Right. I have sine and cosine. That's a problem. If I can put it all in terms of sine or all in terms of cosine, that would be better. It's not easy to turn sine in terms of cosine, but cosine squared, we can write that pretty easily in terms of sine squared. So we're going to do a Pythagorean substitution. And here's where you want to be careful. Place parentheses around there, all right, so that you can successfully distribute once you substitute. What is cosine squared in terms of sine? Somewhere in the distance, a pencil falls to the ground. Did you hear the dog bark? Just kidding. What is cosine squared? Not quite. I know before the quiz yesterday, a few of y'all knew y'all's identities, but hopefully then after you got your tail whipped, you went home and memorized them. 1 minus sine squared. Thank you. There is hope for humanity after all. One bright light burning in a sea of unused LEDs. You just need to flip the switch. You'll have the potential. You just need to turn it into a little kinetic. Cosine squared plus sine squared is equal to 1. So cosine squared is 1 minus sine squared. All right, I've warned y'all several times. If you're interested in learning or getting a good grade, whatever your motivation is, you better memorize your identities over the weekend if you don't know them by heart, because it's about to get real, and by real I mean real fun. Real fun. Okay, so once you do the substitution, then what? We should not factor out sine, but Thornhill, I appreciate you speaking up, right? It's kind of how you get your fire lit, by participating. That's good. Minus 2, I heard someone say distribute, and then plus 2 sine squared of psi. And now this kind of looks like something we encountered yesterday. We have a squared term in terms of sine, a non-squared term in terms of sine, and a constant. We saw that yesterday. What did we do with that yesterday? We factored it, yeah. So let's go ahead and rearrange the terms. 2 sine squared plus 3 sine of psi minus 2. So you got to remember this strategy. Whenever you have things in terms of sine and or cosine and there's nothing to factor out, replace cosine squared with 1 minus sine squared, or replace sine squared with 1 minus cosine squared, whatever the case may be. And now this sets up something that might factor as a trinomial. So 2 sine squared would be 2 sine of psi, sine of psi. And then 2 factors 2 different ways. So you either try it out with the 2, 1 or the 1, 2. It's going to be the 1, 2, and then it's going to be a plus and a minus. So again, at this point, hopefully factoring is not the obstacle for success. Trial and error is better than nothing. All right, so if you factor it and you're not sure if it works, just FOIL it back out, and you'll see that it actually does. We got a product of plus 4 minus 1. That's going to give us a plus 3. All right, so now we set them each equal to 0. So if you set the first factor equal to 0 and solve for sine, you're going to get positive 1/2. And if you set this one equals 0 and solve, you're going to get negative 2. So I'm okay with you doing that. This is pre-AP after all, not academic. So when you do it like this, you're implicitly setting them equal to 0. So you're already solving them for sine in your head. And I did that because I'm running out of room. All right, so now it's unit circle time, everyone's favorite time. What time is it, boys and girls? It's Unit circle time. All right. So where is sine equal to 1/2? Between 0 and 2 pi. Pi 6 and 5 pi 6. Good. And we'll come back to those. And where is sine equal to -2? Anyone? Louder, bird. It's never equal to -2. Oh, man. My osteoporosis was kicking in. I was becoming a hunchback under your eyes. Okay. No solution. Sine is never -2. Sine has to be between -1 and 1. Okay. Feel free to use anything you've learned already up to this point. All right, now, pi 6 and 5 pi 6 are solutions, but are they between -4 pi and 0? Nope. So we got to find the coterminal buddies for each of them. So, and we're going 2 negative rotations. So pi 6 minus a rotation is what? 2 pi is the same as 12 pi 6, right? So if I subtract 12, what's 1 minus 12? That's a better question. -11 pi 6. And then if I subtract another 12, what's -11 minus 12? -23 pi 12. Good. Or 6, sorry. No, 12, 6. 5, 4, 3, 2, 1. Weekend. 6, 6, and 6. Okay, so those are the two that come from that guy. Now we'll do the same thing with 5 pi 6. What's 5 minus 12? -7 pi 6. And what's -7 minus 12? 19 pi 6. There you go. So now we don't need those guys anymore. So between -4 pi and 0, we just subtracted. So you always find the ones in your comfort zone. Hopefully you have that comfort zone. That's 0 and 2 pi. And then you just add or subtract full rotations to get the ones that are in the specified domain. All right. So there you go. Comments or questions on that? Sigh of relief? And now it's over, unfortunately. Okay, now we're on the last section here. Example 11, rapid fire. Ooh, what does that mean? Yeah, and fast is such a relative term, I guess, right? Fast. Mixed practice. Solve each of the following between 0 and 2 pi. You're welcome. You're welcome. You're welcome. No calculator, all right? In case any of y'all were trying to get the calculator out. All right, very quickly here, we got 2 sine of x plus square root of 3 equals 0. You have a single trig function in one term. Goal is to not get it equal to 0, but now to isolate it. If you have a single trig function, and there's not 2 terms of the trig function, isolate the trig function. So that gives you sine of x equals negative square root of 3/2. And now it's everyone's favorite time. It's not Bozo the Clown time, it's unit circle time. There used to be a time called Bozo the Clown time. On WGN, Chicago Superstation, every morning there was a show called Bozo the Clown Show. And, yeah, Bozo was a clown, kind of a creepy clown. He was a fun clown. The people from the studio audience would get selected to come participate in games that Bozo the Clown was leading. One of them was called the Grand Prize Game. And that's how old I am. Okay. So where does sine equal negative square root of 3/2? Oh, yeah, one more time? Oh, sweet, man. We're actually getting rapid fire. 4 pi thirds and 5 pi thirds. Boom, done, finished, listo. Ready for the next. Number B. 4 secant squared of x equals 8. Do you want to get it equal to 0? Say no. No, because there's only a single trig term and not 2 terms of trig. You isolate it. So you divide through and you get 2. Who likes working with secant? Raise your hand. Nobody's hand went up. Great. So we can do it in terms of its reciprocal. If secant squared is equal to 2, then its reciprocal cosine squared should have to equal what? 1/2. Very good. So if you don't like a secant problem at the end, you can turn to cosine. Or same thing with cosecant. Now let's take the square root of both sides. Don't forget to do what? Brush your teeth. And both sides. So plus or minus the square root of a half. Oh boy, the square root of a half. Let's go off to the side and do some bench work. Here we go. The square root of 1/2. That's the same thing as the square root of 1 over the square root of 2. It's the same thing as 1 over the square root of 2, which we recognize more as square root of 2 over 2. Ellie, you getting all this? You seem to be preoccupied with something there. Square root of 2 over 2. Very good. So that is a recognizable ratio from the unit circle. And plus or minus means we want all of them within one rotation. Okay? What's the reference angle here for the square root of 2 halves on the cosine? Pi 4. So we want all the pi 4 angles as we go all the way around. So let's go through quadrant 1. Pi 4. The next one would be 3 pi 4. Good. And then in quadrant 3, 5 pi 4. Now we're cooking with oil. And then finally, 7 pi 4. And the oil's hot. It's at 350. Yeah. It's not like at 100 and you put in the front and you get soggy French fries. Okay, sweet. Comments or questions on that one? Fun, or fun? That's right. It's like the grand prize game with Bozo the Clown. Let's take a quick intermission here. Yeah, Bozo the Clown. Okay, first of all, here's what he looked like. Yeah, there he was. Bozo the Clown, 1966. Look at that. Yeah, isn't he fun? Bozo the Clown. He was on every morning. Grand prize game. All right, you can't hear what's going on, but the kids are going wild. They're going wild, and so is Bozo. Oh, they got the Bozo pewter back then. Sweet. Okay, and then, yeah, he would choose kids out of the audience. They're like, quit touching me. Quit touching me. Quit touching me. He's like, oh, man, okay. And look, they have to throw balls in a bucket. Oh, boy, the pressure's on. This was the grand prize game. Throw the balls in the bucket. Oh, there's another clown. Throw the balls in the bucket. Okay, come on, the kid is nervous. Let him throw the balls. Look at him. Oh, you get a Cabbage Patch doll. You don't have to steal or kill for one. You can just get it. The grand. Oh, there's another clown. Oh, my gosh. All right. Let's cheer him on. The grand. Oh, come on, kid. Did he get it? Did he get it? All right, here he goes. Aim for 3. Hey, he got 3. Look how excited he is. He's been standing up there for almost 4 minutes. Okay, all right. And there you go. Okay. And now you know why I am the way I am. I watch that every morning before school. Yep. It was one of the few channels we got. We got WGN. That was out of Chicago. It was one of the super stations. So it had a strong broadcast signal. So with the rabbit ears, you could actually tune in. And I watched that through fuzz, kind of snow, because the picture didn't come in clear. Yes. Gacy was his name. Yeah, Gacy. Wayne Gacy. Wayne Gacy. My middle name is Wayne. John Wayne Gacy. Yeah. Yeah, he was a clown. He's kind of the guy that gave clowns a bad name. Because before that, you could see how those 3 clowns right there, it was all fun and games. Literally. All right. Okay. 4 cosine x minus 3. They don't show you that kid before he goes out there. They take him to the back and they put on a couple of layers of adult diapers so that when he's standing up there and he's just waiting there for 4 minutes while clowns circle around him and he pees and poops his pants, you don't see it. Okay. Cosine squared, if we solve for cosine squared, add 3 divided by 4, you get 3/4. Okay, so far so good. We're isolating the trig function. Who likes working in terms of cosine squared? You want to put it in terms of secant squared? No, okay. So let's just take the square root of both sides, and we remember plus or minus. So plus or minus the square root of 3/4. Okay, without a calculator, let's go off to the side and do some bench work. The square root of 3/4 is the square root of 3 over the square root of 4, which is the square root of 3/2. Hey, we remember that. That's a unit circle ratio. And again, because it's plus or minus, we want all of them as we rotate around, plus or minus. And the reference angle is for cosine? pi6. So here we go. 1 pi6, quadrant 2 gives us 5 pi6, quadrant 3, 7 pi6, and quadrant 4, 11 pi6. Yeah, now if you forget the plus or minus, you're only going to come up with those two answers, and that would be a mistake, okay? On the test, you're going to have 3 sections, okay? You're going to have part 1. Eventually the test, you're going to have proofs, okay? And you're going to have to do probably 3 out of 5. Part 2 on the test is solve, and you're going to have equations like this that might require some manipulation with identities. And then part 3, you have more proofs, but the proofs on part 3 are going to be the extra fun. We add a little bit dash of extra fun into them, okay? And so eventually when we take the test, that's it. There's no multiple choice. Okay, comments or questions on the first row? Bozo the clown. It's real. Sine of x equals cosine of x. Any ideas? Ideas. We now have 2 trig functions instead of 1. So most of the time you want to get everything on one side and set it equal to 0 when you have more than one term. Can we do anything with that though? No. So from here you could do one of 2 things. You could square both sides, yucky, yucky, gross, gross, and then make a Pythagorean substitution. Or you can actually, in this case, divide by cosine. This works in this case because, are we losing the cosine? No, it's actually getting absorbed on the left side. Sine over cosine is equal to what? Tangent. Ah, so there you go. Now we made the problem easier. So now where is tangent equal to positive 1? Pi fourths and? Not 7. 5 pi fourths, right? In quadrant 3 where they're both negative. So that's the key to unlock that one. This one you can almost do just by intuition. For what angle x do the sine and cosines equal each other? Where are the ordered pairs exactly the same? In quadrant 1 and quadrant 3. So you can do it that way as well. It wouldn't require much work. Okay, you could have also divided by both sides by sine and then gotten cotangent equals 1. You get the same answer. All right, that's rapid fire. So A, B, C, D. E is next. E, 2 cosine squared equals cosine. Do you want to divide out a cosine from both sides? No, 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 no. You lose information because you're going to get rid of the cosine. It's going to be gone. So unlike over here where we divided through by the cosine, it was gone on this side, but it stayed on that side. Okay, that's the difference. So instead we'll bring it across, set it equal to 0, and now do what? Factor out a cosine. Had it been sine squared and cosine, we would have done the same little trick with the Pythagorean identity, but they're already in terms of cosine. So we factor out one of the cosines, and we're left with 2 cosine of x minus 1. So you set them each equal to 0, cosine of x equals 0, and that's the equation you would have lost if you divided out the cosine from the beginning. And then cosine of x would equal what? If you set 2 cosine minus 1 equals 0 and solve for cosine, you get cosine equals 1/2. Yeah, and that's fine. If you want to set it equal to 0 in your head and solve, this is fine. This is all I really need to see. And now it's time for the grand prize game, which for us is unit circle time. Unit circle time. Where is cosine equal to 0? Pi halves and 3 pi halves. Good. Rapid fire. And where is cosine equal to positive 1/2? Pi thirds and 5 pi thirds. Sweet. It's all coming together. Everything's coming together. Unit circle, algebra, math, reading, right? Vision, sight. You got all your senses involved. You see it. You smell it. You'll smell it. Kind of smells like mountain laurel a little bit, doesn't it? Y'all ever smelled mountain laurel when it's in full bloom? Makes you want to eat it. Wow. Okay, just me. But remember, I grew up watching clowns every morning. All right, we got one more. Oh, boy. If we finish this one in the next 19 minutes, we finish the notes. A joke. It's student athlete day. Anyone have a joke about a student athlete? Let's go for it. 2 plus 2 cosine equals sine. We got more than one term with the trig function in it. So we typically do that. What we've been doing, bring everything on one side, set it equal to 0. If you just have a single trig term, you want to isolate it. Now we have a squared term, a non-squared term, and a constant. Does it factor in this format? Nope, because we have it in terms of cosine and sine. That's not good. If they're both cosine or both sine, it would work. So we need to try and get it now in terms of either sine or cosine. Well, it's going to be hard to turn a cosine into a sine with an identity, but it wouldn't be very hard to turn a sine squared into a cosine squared. So whenever you make trigonometric substitutions, I highly recommend parentheses. Notice there's a negative in front of there. See that? So when you do the substitution, that negative is going to have to be distributed. So here we go. Parentheses again. And this is a chance for redemption, right? Let little Johnny come back out, dry off his pants a little bit, and let him go for bucket number 4. Sine squared is, in terms of cosine, 1 minus cosine squared. Very good. Very good. All right, and now we have to distribute 2 plus 2 cosine of x minus 1 plus cosine squared. And now we'll collect like terms and write it in descending order. You have a cosine squared plus 2 cosine of x, and then your constants, 2 minus 1 is plus 1 equals 0. And then we go to factor it. Something, something times something, something. Well, the leading coefficient is 1 now. Yay! So that's got to be a cosine squared, or a cosine and a cosine to get a cosine squared. And then we have a 1 back there. Yay, that's got to be a 1 and a 1. And now the middle term has to be a positive 2. So both of these have to be plus 1. Which means we really have the same factor, don't we? So it's the same actually as cosine of x plus 1 quantity squared. So you really only have to set one of them equal to 0, which is now the same as cosine equaling negative 1. And now, boys and girls, one last time this week, it is unit, circle, time. But really it's time, circle, unit, because we're using the unit, circle in reverse. So it's time, circle, unit. Where is cosine equal to negative 1? Within one rotation. Pi. 2 pi? No. 3 pi? Not in the rotation, not in the domain. So just pi. X equals pi. So we end the week on a sweet note. Pi. Pi. It could be cherry. Could be chocolate cherry pie. I never had that. You ever had mincemeat pie? There's no meat in it. Okay? It's actually like just a lot of cloves. Yeah. It's kind of good if you like cloves. Yeah. It's very, very spicy, like cinnamon type stuff. Yeah. All right. Any comments or questions? We're going to make the worksheet due on Tuesday, not Monday. Yeah, you're welcome. I don't know why. We're going to make it due on Tuesday. Monday, we're going to practice some more of this, okay? Practice some more. And be ready for like a pop quiz on Monday over maybe regurgitating your identities and maybe using them to solve an equation. Yeah. Yeah. You got to learn this stuff. Possibly. Yeah. After yesterday's quiz, I think I need to put the pressure on a little bit more. Some of y'all are kind of slacking up a little bit. You're not doing your due diligence. And you have to have your arsenal fully armed before we head into the next section, which is full-on trig proofs. And if you don't have, if you're not ready to go, you're gonna fall behind. And it's really hard to get caught up in this section if you don't have everything you need. So memorize your identities. Practice, practice, practice. You probably want to complete the worksheet by Monday so that you're ready for any pop quiz on Monday. But we're not going to have you turn it in until Tuesday. So there we go. We'll stop with